So this is section D, part 2, question number 3. So it says, what is the pressure of 2.3 moles of carbon dioxide at 235 Kelvin, occupying 23.7 liters of space? So again, the first thing we've got to do is identify, are we going to be using that combined gas law or the ideal gas law? So for this one, we know we're going to be using the ideal gas law, first off because the title of the section is Ideal Gas Law Practice, but the other reason is because it gives us specific quantity. So it says 2.3 moles of carbon dioxide. So anytime you see moles or grams in a problem, you're going to have to use that ideal gas law. So it's going to be PV equals nRT. So we have all those variables, nRNT. R is always the easiest one. That's our combined gas constant or our gas constant. So liters ATM per Kelvin mole. We pull everything else out from the problem, so it's asking what is the pressure, so that's our unknown, of 2.3 moles. We can add that as CO2. The temperature is 235 Kelvin, and the space or the volume is 23.7 liters. So first off, make sure all our units are good to be plugged in, so volume is in liters, moles is good, universal gas constant is always good, and the temperature is in Kelvin, so we're good to plug in. What I like to do first is go ahead and manipulate that equation from the start so that you can get pressure by itself. So right now we see P multiplied by V. Do the equal and opposite, so divide both sides of this equation by V to get P by itself. Let's go ahead and rewrite it. Now that P, or pressure, is by itself, we're going to go ahead and plug it all in and solve. So N, number of moles, 2.3 moles, that gas constant. The temperature divided by our volume, 23.7 liters. All right. Those units, we can check them once again. They are all going to cancel. So it's going to be mole to mole, Kelvin to Kelvin, liter to liter. So we know our final answer will be an ATM. The other reason we know it's ATM is because it is the pressure. And if we're using the ideal gas law, with this specific gas constant, our pressure will always come out in atmospheres ATM. So let's plug it in. Make sure we use those parentheses. So open parentheses to plug in the top. 2.3 times 0.0821 times 235, close parentheses, there's our top, divided by 23.7, oh, sorry, that is a mistype. Our temperature was 235. Oh, sorry, my mistake. This is the volume, so that was correct before. So it's still 23.7 liters. Oops. I thought it was a mistake, but it was correct. So we do divide by that volume, 23.7, hit enter, and we get 1.87 ATM. Awesome.